Welcome to this video, which has been made by Malvern Radar and Technology History Society, better known as MRATHS. We were founded to celebrate the extraordinary legacy of scientific research in Malvern. How many of us know that scientists and engineers in Malvern enabled so much of what we take for granted today? The development of the magnetron has given us the microwave oven. A system called G set the mathematical foundations for GPS and thus our sat-navs. The touchscreen, invented to help radar operators, is now in all our digital devices. Thermal imaging has given us the ability to see heat, and that is the subject of this video. For thousands of years, humans have seen rainbows in the skies on rainy days. But it was not until the start of the 19th century that we realized that there is energy from the sun beyond both the violet and the red ends of the light spectrum. The wavelengths beyond the red became known as infrared, and we can form images of this energy given the right sort of camera. Well, this is just the sort of camera we need. It gives us a 256 by 256 pixel image. So no HD video here. However, it does give us a good image of objects around us and shows which are warm and which are cold. Let's look at a thermal image, and we've set the camera here so that hot objects appear white and cold objects appear black. This is me, and you can see that I'm warm compared to the background. Ignore all the numbers down the left hand side of the screen. This camera is designed for use in a scientific laboratory. Let's look at the wall in my study and compare what the thermal imager sees with what we see. I put a normal TV image on the left and the thermal image on the right. In the normal video picture, we can see just the painted surface of the wall. However, the thermal image on the right does not show colours at all, just the surface temperature. As it's cooler outdoors than it is in the study, and the blocks are a better insulator than the mortar between them, the mortar is cooler and appears darker. Finally, the plaster on the wall, which is thin enough to carry the contrast in temperatures to the surface, allows us to see this relative difference. Now let's look at an experiment to show how it all works. This is an ordinary radiant heater with elements that get hot and glow while radiating warmth into the room. Let's turn out the light to see this more clearly, and we'll see what happens. The images are arranged before. Let's turn the heater on. Notice how fast the thermal imager registers the heat and how long the visible glow takes to start showing up. This is because objects that are cooler radiate energy further into the infrared and further away from the red end of the rainbow. As the element gets hotter, it radiates energy at shorter and shorter wavelengths until we see the glow. It doesn't stop there, of course, and the glow becomes orange, and finally, if the element gets hot enough, it becomes yellow. Right, well, if I run my fingers over the carpet gently, you'll see a faint print. But if I start to rub hard, we can generate some heat with friction. Let's just have a bit of a play. It's quite fun, isn't it? Of course, this is friction causing this, and it heats my fingertips up as well. In fact, if I go at it a bit harder, we can really build up some heat on those fingertips. Before it gets too painful, I think I'll stop. Here's an ordinary drinking glass. Let's just put a hand in now, and the visible, you can see it's almost completely transparent, as you'd expect. But look at the infrared. You can barely make out a ghost through the glass, and this is because glass is opaque in the infrared, which means we have to make our lenses out of germanium, which is transparent in the infrared, but strangely it's also opaque in the visible. It's not what you'd expect. Well, we've got our drinking glass. Let's just put some hot water into it from the kettle. Now you can see, there's dropped a bit on the table, but you can see the heat now spreading out through the glass, and more of the glass is hot and you can see the cool areas just gently merging in together as the heat spreads out to the outside. This is an ordinary plant mister with some water in it. Let's see what happens if we squirt a bit of it onto the curtain. Here we go. Now don't forget that dark is cool. So what's happening here is that of course the water is evaporating. The tiny droplets of water are evaporating off the curtain, and as they do they're sending areas of the curtain darker and darker. You can see the individual little spots of water. It's quite fun. While we're talking about evaporation, this is my fingertip. You can see the little dark spots which are the sweat glands, because the perspiration, the sweat, causes your fingers to cool down. That's how we basically control our body temperatures. Now if I can keep it in focus, and it's very difficult, this is the palm of my hand, and you can see there are some more sweat glands. Of course our entire body is covered in sweat glands, and it's an extremely good way of dumping heat in the summer. You just put moisture up onto the surface and it evaporates and keeps you cool. Right, enough of the inside of my house. These are some thermal images that were taken at the Severn Valley Railway using both a visible and an infrared camera. Notice the caption up at the left hand corner tells you which is which. Right, well this first of all is visible picture. There's the infrared. And can you see how hot the engine is? Boiler's probably at 200 degrees Celsius. You can see steam coming off the funnel. Back to the visible again, and it's misty so you can see hardly anything at all. Back to the thermal, you can still clearly see the train, and actually you can see two people standing in the field on the right hand side of the centre. Of course no chance of seeing them there, but you can just about see the train disappearing into the distance. Go back to the thermal to round the other bend, and you can see the wheels and everything are warm from the brakes rubbing on them. And back to the visible, and there we are, disappearing from view. Gone. Finally, let's take to the air in a Blackburn Buccaneer aircraft which has been modified for night flying. Here's a photograph of a Blackburn Buccaneer, which was the Royal Navy's main strike aircraft, for many years operated on and off aircraft carriers. The modification was to remove the nose cone, the black nose cone you can see, and to replace it with one which had a thermal imager fitted. And the pilot had the thermal imager displayed down above his knees, and you can see also that here he's wearing night vision goggles to aid his view out of the cockpit, because all the flying you're going to see was done in total darkness. So let's now hand over to the cockpit video.
This elevation of lights out here is where the railway splits right.
That's right, there's the
road bridge we've just gone over, and so it's follow it round the main valley round to the left.
Looks different by night. I've not flown it for a bit. Okay, here we go then.
What do you mean you didn't fly it for the weekend?
No, I mean at night. It's easy by day. Okay, here we come, that's right, here's Little Village. Okay, on 010, here's a Little Village.
It's fine. We've got the road to follow up here, which is good. The river's still in the bottom.
Okay, and then we don't go...
no, you go left round the spur, don't you?
That's right, left round the spur, then sharp right.
Yep.
Okay. And here's all my nice big wood on the side of the hill.
Yep.
Coming up to the turn. Can't see it yet, there it's starting to come now.
Up the turn. That's fine. I'll see where you got to go. Got to reverse in a second.
And contact everything. All the way around here.
Yeah, that's it. Straighten up. Kink right, then a kink left. Over this little spur here.
got the road
I've
going
got
up
the
to the
road
wall.
running up it, yep, and me. That's fine.
Going on. Nice shadows.
Yep, snow on the hills.
Watch for the rad out unlocking.
Yep. And just be prepared for the noise.
That's a nice blind one there.
Yep.
Go over the top now.
Well, I hope you've enjoyed that short video, and that when all the current crisis is over, that you'll come and hear our speakers in our public meetings. Thank you very much. Bye-bye.